Alright, so today we're going to be looking at section 2.3, part A. We're going to be using, if you don't have this book, I can send it to you. It's online as a PDF, I'll send it to you. Just let me know and I will make sure it gets to you. But we're going to be looking at problems 1, 5, and 9 specifically, and then we'll talk about the middle problems a little bit later. So first we need to find our formulas, and our formulas happen to be on page 66. And right here I've got all the problems written out, so we don't have to worry about that. This is 1, this is like 5, this is like 9. So this is a circle, this is a cone. Alright, so we know the first one is a rectangle, we want to find perimeter and area. So down here, P is the perimeter, so this is our formula, so we're just going to use that. And we need a calculator, so we're going to pull that up. Alright, so now that we have that,
she is so gorgeous.
so we have our formulas, we have our calculator. So what we're going to do is we're going to take this, and this first one is saying that we have a rectangle with a length of 5 and a width of 7. So if our width is L and our width is W and our length is L, then our perimeter will be just 2L plus 2W. So we take 5 times 2 plus 7 times 2, which is 10 plus 14, which equals 24. Alright, so our first perimeter is 24. The second one we can do the same thing. 24 or 14 times 2 is 24, 28. And we're going to add 3 plus 2, which is 6. And that equals 34. So the perimeter is 34 on that one. The perimeter on this one's going to be a little harder to find because we've got decimals, so we record numbers somewhere. You'll have your paper to record numbers with, but this is how we record numbers here. So we'll just do it like this. We'll say we need, again, we're just following perimeter, so it's 7.2 times 2. So it's 14.4 plus 18.34 times 2. 36.68. We take those and we set those equal to whatever that equals. We'll just add 14.4 to that. Our perimeter for this one is 51.08. Now area is a little easier. Our formula for this one is A equals L times W. So that's easy enough, right? We just take our length times our width. In this case, 5 times 7 is 35. 14 times 3. 42. Alright, now this one right here is going to be 7.2 times 18.34. So we take 7.2 times 18.34. The area of this one is 132.04. That's where those values come from. You should be able to fill in the rest of the table using that. Remember, the formulas are going to be P, 2L, it's 2W, and then it's also going to be, sorry, it's up in my eye, A equals L times W. Alright, now for the circle we're going to find on here where it's got a circle stuff. Right here. So this is a circle. Oh, there we go. So this is a circle right here. So we know our equation is going to be 2 pi. 2 pi r for circumference. So circumference is c, radius is r. That's going to be important. Radius is r. Circumference is c. And area is some sort of A. Alright. Now this should give us our value. So, and remembering that pi is just a value that So pi is just a value that equals 3.14596, yada yada yada. So pi will always equal that in our equations. And our calculator might be able to do that if we switch from a standard to a scientific. And if we see there's our pi number right there. So that'll make it easier when we do the equation. So this first one is going to be 2 times pi times 3, or the radius. Right? So we plug all that in our calculator and we say 2 times pi times 3 gives us 18 point blah 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 blah, but we just need the first 2. So our circumference is 18.85. Which means that our area will be a similar number. But area is just pi r squared, so this is going to be a different one. This is going to be, for if you're doing area, your function is different. It looks like this. It would be pi times 3 to the 2. So on your calculator it looks like this. You would say 3 to the 2 first. So let's do that. 3 squared times pi. Oh, not 7 pi. This gives us 28.2. So our area is 28.27. Right, now this one it's 12 squared times pi. Oops. Pi. It's 452. So this one is going to be our area. So since we did 12 squared times pi, this is 452.38. 452.39. Now let's do circumference. We're going to do it backwards here. So this is 2 times 3.14596 times 12. So you just keep plugging in the number that changes, the r. And if we look over here in our formulas, the r is the only thing that changes. Everything else is a constant by circles. Now, let's see. We're looking at this. We say that that's times that equals, let's see, 2 times pi 12, 75.39, 75.4. So 75.4. And then the similar thing applies to this 5.1. We just take 5.1 times pi times 2. So it's 32. So that gives us 32.04. This one right here, 5.1 times squared. Squared. 5.1 squared. So that's 26.01. And times pi. 81.71. Now, just a clarification, when you're using your calculator on your computer, you can change between standard, which is your basic number calculator, won't give you pi or anything, to scientific. This will give you pi and other things that you need to know when you're doing other things like sine, cosine, which you're not doing yet. But pi is going to be the most important thing you're going to use on this calculator. This calculator you will never use. This is for programmers who are switching between different languages. And these are converters. You can convert volume to other things, length, weight, mass. But the ones you'll need to know are scientific and standard. Most likely you'll see scientific, so let's use that. This is what we've been using for this to find pi. Now this next shape that we're working with in 9 is a cone. It is it's going to be a third degree. So it's a three-dimensional shape. So therefore, it will have three things that we can look for: lateral surface area, which is just like related to circumference or perimeter. That's what a cone is. Lateral surface area is the cone. So that one's pi RL. So the things that change here, we've got two things that change. The slant height, which is L. So this one is actually strange because they call it L, right? The height they call H, which makes sense. The radius they call R, which also makes sense. So when we're plugging into our equations here, we've got two things we have to worry about now. We have to worry that we're going to do that. Alright. So what we're going to do is we're going to take and find the lateral surface area. So our lateral surface area is pi r l. So we're going to take our calculator and say, well, our radius is 5 and our height is, or our slant height is 5, or 3. So 3 times 5 first, because that will give us 3 times 5, or r times our L, times 3.14596, so pi, times pi. So this pi value is pi RL. If we just multiply all that out and then we hit times pi, this gives us 42.12. This is our lateral surface area. Okay, and now we're going to look for just surface area, which in this case happens to be a little more complicated of a formula. So we're going to have pi r so pi r squared plus pi RL. So our first one, right here, pi RL, our lateral surface area. So you recognize pi RL from our lateral surface area equation. So if we take the lateral surface area and we add that to pi r squared, that should give us what we're looking for. So if we take this and we say pi times, oh, I need to clear everything. Clear everything, okay. So we take 3 squared first. Square that, multiply it by pi. And then we say, well, that's cool, but now we need to add our 42.12. Because now we're adding that other portion of the equation. So we do this first portion, then we add the second portion, which we've already found, giving us 70.3.4. Oops. My volume is going to be an interesting one, because this one's where we have 1/3 pi r squared h. So we're taking volume. We have two constants. We have a 1/3 and a pi times pi times our r squared, which in this case happens to be 3. The caret means squared. Times our height, which in this case is 4. Because this time we're using height, not L. So this time we're using our h, not our L, and so that's a big key difference. So now we take our calculator here and say 1 divided by 3. What's that give us? Oh, that's cool. Gives us a really, really long decimal. Multiply that by pi to get an even weirder decimal. Alright, that's a really weird decimal. Now we're going to take that and we're going to multiply that by 9, which gives us that. And then we're going to multiply that whole number by 4. That's our volume. The inside of that cone has now been determined as a number. We know that there's 37.7 squares, or cubed, inches, cubed, whatever, inside that cone. Now let's do this one real quick. Let's do this one so you can see that all done again. And if you need to, just watch this video multiple times till you get it. I know I will be going fast, but I'm doing it so that you can get the information, and then watch the video as many times as you need to get it down. So the first one, again, we take our pi RL. So we take our pi times our 5 times our L, which is 13 in this case. And that gives us 204. So this one is what we're looking at, lateral surface area. 204. So our lateral surface area will be 204.2, which means that that is our surface area as it pertains to going straight down the cone. Now we're going to find the surface area at the bottom of the cone. Or the surface area for the total cone, because this is just the straight down. Now we're going to find the bottom of the surface area, the bottom cone surface area with that lateral surface area. We're going to find the whole surface area of the cone. So now we're going to take that number, but we're going to take our pi r squared. We're going to take 13 squared So pi r, sorry, pi r, not 13.